All right. This is the first lesson on limits, and I'm going to go over some things and some definitions before we start the actual notes worksheet. So if you'd be paying attention, that would be great. We talked about when a graph was discontinuous before, when it had an asymptote maybe. Okay, so it was doing something like this, or we had a graph that was a piecewise function, so maybe it had some crazy absolute value over here, then over here it had a parabola or something, and it was discontinuous or had a gap in the graph here. Okay, we're going to talk more. We did not talk about limits back in chapter 1 like it says here. We're going to talk more about limits today. All right, this slide I put in here because it talks about calculus centers around two fundamental problems: finding the equation of a line tangent to the graph of a function at a particular point, and finding the area beneath the graph of a function between the graph of a function and the x-axis. Okay, so those are some ideas you will take into calculus and learn more about. The fundamental to these solutions, though, is the idea that a graph can have a limit at a point even if it's undefined there. As you get closer, if I ride this down, this graph, I get closer and closer to a y value of L. If I take this and go upwards along this graph of the function, I get closer and closer to L. So even though there is a hole here at the graph, this blue, is it blue, line has a limit at C of L. Okay, now what you're going to be told is the limit approaches C as the x value. The answer you want to give is what y value it's approaching. Okay, so that's the important thing here is we need to remember always we're looking for a y value. I'm not going to spend a lot of time on this. You guys know this is an equation of what? Negative 3x plus 1 is a line. Does it have any holes in it? No, it's just a line. So at 2, if you look at the graph, as you get closer and closer to an x value of 2, you will get closer and closer to a y value of negative 5. And here's they put in a table and they put in values closer and closer to 2 coming from both ways, guys. So below 2, 1.9, 1.99, 1.999, and above 2, 2.1, 2.01, 2.001, and from both directions it's getting closer to negative 5, which is actually the value at 2. Okay? We'll talk more later this week about this is a problem that can be solved by direct substitution. You can just put in a 2. All right. This graph does have a hole. Do you remember we factored these kind of rational functions and we found an asymptote? It had a hole at 3. So when it says the limit as x approaches 3, it's actually undefined at 3. But as you get closer and closer to 3, what would values just below 3 be that are getting closer to 3? What's below 3, guys? 2. What's really close to 3, but not quite? 2.9, 2.99, 2.999, okay? What about values above 3? 3.1, 3.01. You want to get closer to 3 all the time, okay? 3.001. When you do that, this graph gets closer to 3. Even though it's undefined at 3, it's said to have a limit because it approaches 3 from both sides. All right, when we do this and we're looking at the table instead of the graph, I think it's much easier. They say you can go through and adjust the table set. My suggestion is you put on ask and auto. We've done this before, but I'm going to have you go to the table set and put on ask and auto, and then we can just type in values closer to the goal and see what we get out for y values. All right, this is the concept of a limit, okay? Close attention here. Independence of a limit from the function value at a point. So this particular first graph here has a hole at C. The limit at C is undefined, or the function, I'm sorry, the function at C is undefined, has a hole. But the limit at C is still defined because you're getting closer and closer to what y value from both sides here? L. Okay, so the limit is L. This one is not undefined at C, but at C it's clear up here. See the dot? But that doesn't matter that the value at C is up here at N. If they ask you to find the limit at C as x approaches C, you say, well, from the left it's getting closer and closer, and from the right or the below it's getting closer and closer to L again. So the limit is still defined. And this one seems pretty obvious. It actually has a value at C, so the limit, as you get from the left or from the right, it's continuous, so the limit is still approaching L. All right. We'll talk about when it doesn't exist in a minute. It's important to understand, though, that a limit is not about what happens at the number that is x. Instead, it's at what appears to happen near or very close to that number. All right, we're going to talk about left side, right side limits today. Do you remember seeing this before? We had this business. It would say, we just did it a couple times. I think it was actually in the chapter on rational functions. This means approaching 3 from the left, and this means approaching 3 from the right. Do you kind of remember that? Maybe once we talked about it? Okay. As x approaches C from the left, we would indicate this C with the negative behind it, not in front of it, okay? Up above, like a exponent. And it's read as x approaches C from the right when it has a positive up in the exponent after the number. That's just how to read it, okay? A two-sided limit exists only if it approaches the limit as x approaches C from the left is exactly the same as the limit as x approaches C from the right. Okay, and both of those are L, then the limit at C is said to be L. Okay, one more time in words, it says the limit of a function as x approaches C exists if and only if both one-sided limits exist and are equal. If they're not equal, then it doesn't exist at that point. So you can have a left side limit and a right side limit and still have no limit exist at a point, which is what's going to happen on this example, which is just like one on your notes in a second here. This is the graph of absolute value of 2x over x. Notice on the left side of 0, so as x approaches 0 from the left, what is the y value getting closer and closer to? -2. Does everybody see that? Okay, the y value is getting close to -2. So you would answer that if it asked you what the left-hand limit is, or what it's approaching from the left, you would say -2. From the right, if you're coming at 0 from the right, your x's are getting closer and closer to 0. What y value are you approaching right here? +2. So we say the limit as x approaches 0 from the right is 2. Notice, though, that if you asked me the actual limit at 0, it does not exist, because if it approaches from at the left to one value and the right to a different value, then at that point it said not to exist. Okay? All right, this one has a hole, but as you approach from the left or right, the y value stays at 4. Okay, so even though there's a hole at -3, as we approach -3 from the left or right, we still say the limit is 4. And the limit at -3 is said to exist because it is approaching 4 from both sides. All right, we're going to skip to this question that's on your homework, or notes, I should say. The limit as x approaches 2 from the left of this, do you remember this step function thing? Okay, it's also called the round down function or the largest integer function. As we get close to an x value of -2, which is right here, no, it's not -2. My bifocals are playing games with me. This is +2 from the left, right? As you get it closer and closer to +2 coming from the left, what's the y value staying at, guys? 1. All right, this one says as you approach x from the right. Well, if you're at 3, then 2.5, then 2.1, 2.01, what are you getting closer and closer to in terms of a y value? All of those have a y value of 2. So from the left it was getting closer to 1, from the right it was actually at 1, from the right it was at 2. So does it exist when you're sitting at 2? If from the left it was 1 and the right it was 2, does it actually exist at 2? No, because it's approaching 2 different values. Okay? As x approaches 2, they're not the same, therefore the limit at 2 does not exist. This is hard because you got to pay attention to this little tiny negative here, this little tiny positive here, and the fact that there isn't one here at all. All right. Estimate each limit if it exists. At 4, if I put a 4 down in here, guys, what happens? 4 minus 4 is 0 squared, 1 over 0 squared is undefined. If you graph it, there's an asymptote at 4. Okay? As you get closer to 4, the value of the function increases. It does what we call increase without bound. Okay, it just keeps going up and up and up. If you put this in your calculator and you type 3.9, 3.99, and then you type 4.01, 4.001, it's getting huge. Okay, it does not approach a particular value. Neither one side limit at 4 exists because it's just going towards infinity. Okay, therefore we can conclude that the limit at 4 does not exist. However, both sides are going towards infinity, so we can describe the behavior at 4 as approaching infinity. So they will say it approaches infinity. All right? But it actually means the limit doesn't exist. It just, because they say it doesn't exist because infinity doesn't have a limit. Does everybody understand that? It's not a particular number. So we will still describe it as approaching infinity. All right, I used those words without bound, increasing without bound. Okay, it is important to understand one more time that the expression x approaches 0 from the left, the function approaches -infinity, and if the limit as x approaches 0 is infinity, are descriptions of why these limits fail to exist. The symbols infinity and -infinity do not represent real numbers. We still describe it that way, though. All right, we've talked about this in the past. This is called the reciprocal function. If you are approaching 0 from the left, which way is this thing going? Y values are going down towards -infinity. As you approach from the right, y values are going, up. Okay? Here's examples from the left side of 0, the right side of 0. All right, so they would say the limit at 0 does not exist. In this case, we cannot describe the behavior because its left and right sides differ. Another possibility we will have is that what's called oscillating behavior occurs. This graph would not have a limit at 0, okay, because on either side of 0, it's just bouncing up and down between two exact values. All right, so these are the 3 reasons a limit cannot exist. If the left side approaches a different value than the right, if it increases or decreases without bound on the left and or right, or if it oscillates between 2 fixed values, which happens very rarely. Okay? You have this in your notes. We're finally going to talk about our notes here. This means as it approaches C from the left, as it approaches C from the right, and the existence at a point of a limit occurs if and only if both one-sided limits exist and are equal. Then the limit, if both of them approach, left and right approach L, then the limit is L. All right, type this in your calculator. Anybody remember where the absolute value is? You need to be in function mode, and we're going to do a couple trig functions in a minute. So could you also put it in radians before we go any further? Make sure you're in functions and radian. Function mode and radians. Then go to y equals. Make sure your plots are turned off at the top. We were doing some stats last week. If there's a darkened box up here, like this, just go up arrow, enter, until those are all just the words plot 1, 2, and 3 without any boxes around them. All right. I think it was Daniel said under math, arrow to the right once. There we go. Absolute value. 3x. Now, if you have an older calculator, you have to close the parenthesis at this point. Otherwise, you just scroll to the right to get out of that little box, or little absolute value symbol, and then divide by x. Okay, I'm just going to do a Zoom standard to start. Okay, we had a graph looked vaguely like this a minute ago in the notes. What do we want, though, for this particular question? What is this asking? 0 from the right. Good job. How is it approaching? What y value is it approaching as we approach 0 from the right? So if I did trace and I said 1, I'm at 3. If I said 0.9, I'm at 3. If I said 0.1, I'm at 3. If I said 0.001, I'm at 3. Is that close enough for you to get that it's staying at 3 as it gets close to 0 from the right? Now, does this problem, this graph, have a limit at 0? If it were approaching from the left, what y value would we have, guys? We'd have -3. So if it approaches from the left is -3, and from the right it's +3, does it have a limit at 3? Or at 0, sorry. No, because it's approaching 2 different values. Very good. All right, try this one. Again, it has an absolute value. X minus 2 divided by, what do we need around the bottom, guys? Parentheses, right? X squared minus 4 is in the denominator. This time we have an asymptote at -2. Everybody got what's going on here? Which side do we want to know about? This means -2 from the left. Okay. You could do trace. If you put in a -2, it will say there is no value. If I arrow to the left once, it says my y value is 8.25. What are values close to -2 on the left? just to the left of negative 2. Okay, negative 3. Well, at negative 3, it's at 1. How do you get closer to negative 2? Negative 2.1. Okay, I'm at 19. Negative 2.01. I'm at 100. Good job. Negative 2.001 or 0.0001. What's the value doing? Yeah, it's approaching infinity. This did not ask us, so actually this limit does not exist. The graph increases without bound towards infinity. Does not exist. It actually does not exist, but we say it's going to approach infinity. Was that math contest this week? Nerdy math shirts on everybody. Does not exist. It's a big thing. Some school had the limit of their intelligence does not exist or something. Or their egos do not. The limit of their ego does not exist. Yes. Okay. What's happening here? Can you graph this one? It wants to know the limit at 2, so we need it to approach the same value from the left and from the right, correct? At 2. Oh, I have my other calculator out. I don't know why, but sorry. Just switching back and forth here. X squared plus 3x minus 10 with parentheses divided by quantity x minus 2. Does this graph have an asymptote? Whoops, zoom 6. It does not have an asymptote. Come on. But if we go trace 2, it's undefined, it has a hole. What's just to the left of that? $1.9 says 6.9. 1.999 says 6.999. Yes. When I did trace, I just am typing in values to trace. Is yours showing up? Yeah. Okay, the other thing we can do, guys, and if you go second window and make sure it says ask and then auto, ask and then auto, then go second graph, and now we could type in some values. We could say we want close to 2, so 1.9, 1.99, 1.9999. And then from the other side, I need it to approach the same value. What is close to 2 on the other side? 2.1, 2.0001, 2.000001. Okay. Is it approaching the same value from both sides, guys? Can you see in my table there? I have 6.9, 6.99, 6.999, 7.177. Okay. It approached 7 from both sides. We looked at the graph and we looked at the numerically supported that word from the table. All right, this is a trig one. So I'm going to put in it's in parentheses. It actually doesn't need to be, but 1 minus the cosine of x squared. You can put it on the outside of the squared like that. I usually type this 1 minus parenthesis cosine of x, parenthesis and square that, but it's the same thing as you'll see in a second here. If you do zoom trig this time, why is it all above the x-axis? Cosine usually goes above and below. Mine's changed colors because I wrote the equation in two different ways, so it graphed it twice. But I just wanted to show you that it didn't matter which way you typed it in. Right, because the cosine value got squared, so it came out all positives. Okay? Now, we want to know what's happening at 0. Okay? If we trace at 0, what's it at? It's at 0. If we go just a little to the left, it's at the y value is 0.01 or something, right? If we go a little to the right of 0, the y value is 0.01. Does it seem like the answer is, what's the y value when x is 0? Okay, we could go to the table if we wanted. We need values close to 0, so like 0.0001 and negative 0.0001. Okay, I got weird scientific notation answers here. Okay, but what is 1 times 10 to the negative 10? It's basically 0, and 1 times 10 to the negative 8th. Okay, both very tiny numbers, so this is approaching 0. All right. Let's try one more. And then I'm going to do some other information here. Oh, I think I'll do this one in purple. Okay, now I managed to make it big so that it's covering up everything. X cubed, no, it's x squared, my bad. Plus 27. What am I doing wrong? I've already messed up. Yeah, I need a parentheses around the top. Divided by x squared minus 9. Anybody got an answer yet? What's it doing at 3? I'm still in zoom trig, I think. If I do a zoom 6 standard, it's a little bit better. What's it doing at 3, guys? At 3, it's undefined. At 2.999, it's at negative 6,000. At positive 3.0001, it's at 60,000 or 600,000. Well, to the left, it's approaching what? To the left of 3, it's approaching negative infinity. To the right of 3, it's approaching positive infinity. So what do we say about the limit as x approaches 3? It does not exist because it's approaching 2 different values. All right, I'm going to actually jump to the next concept so we don't run out of time, which we already are, but I'm just going to do a couple of these. This says what happens as x approaches infinity. So this would mean on the far right and far left hand side of the graph. What's this doing? Okay, we've talked about this as end behavior, yes? Okay. So if there is a horizontal asymptote, then it will approach some constant. Many times it will approach This one approaches 0. As you go to positive infinity, do you see it's getting closer and closer to 0 off to the right? They put some really big numbers in and it was getting tinier and tinier. It's approaching 0. This particular graph has a horizontal asymptote, so it approaches 2. Notice it approaches 2. The y value is close to 2, whether we're at negative 100,000, negative 10. As x approaches negative infinity, it's getting closer and closer to 2. I need you to look up real quick and realize this does not have a right-hand limit because of the oscillating, but it does have a left-hand limit. If I said to negative infinity, this graph is staying really close to what? 0. So even though a graph oscillates, it can have a limit on one side or the other. All right. You have this question. What is this graph approach off to the right? They put in a chart and show you that no matter how big x gets, y is getting closer and closer to 0, so you would say it approaches 0. All right, I just want to do these two real quick. Type this one in. Two x plus 1 in parentheses divided by x. Standard window. And it wants to know as it approaches infinity, what is this graph approaching on the far right? What do you think? Now, you cannot just do this by tracing. My window only goes negative 10 to 10, so if I go trace 9, it says I'm at 2.111. But if I try to go trace 99, it gives me an error because it's not in my window. But if I switch over to the table, as long as I have it set up ask and auto, then if I switch over to table, I'm trying to approach infinity, so I'm going to put 999, 99999. I could put 1, 0, 0, 0, 0, 0, 0, 0, 0. Okay? What's happening? The y value is getting very close to 2. Now it looks like it's exactly 2, but if you go up here, yeah, it's actually not. All right. Does anybody remember the reason for that? Do you remember how we did the graph of that function? Degree of the numerator is equal to the degree of the denominator. Y approaches leading coefficient over leading coefficient. So what do you think this is going to approach? Negative 3 maybe? This time we do want the left limit. Okay. Parenthesis, negative 3x plus 1 divided by x minus 2. I'm going to throw this out there while I'm typing. This is not on the quiz tomorrow, obviously. It is not going to have a separate quiz, I don't think, but it's on the final. There's a couple limit questions on the final, okay? We're going to have a homework check probably due Monday on this. All right. So we are thinking as x approaches negative infinity, what could I type? Looks like it's getting down there. It does look on my graph almost like it just keeps going more and more negative. But if I go to the table, what are some negative infinity kind of numbers? Okay. And my calculator says negative 3, even though when I go there, it's actually negative 2.9995. Okay, so what do we want to answer? It's approaching negative 3 or equals negative 3. The limit equals negative 3. Okay. We will continue with this lesson on Wednesday for those of you who are here. I realize a lot of you are gone Wednesday. It's just going to be more of the same, okay? It's not like I'm tricking you. I'm leaving half the important stuff out. So if you're not here Wednesday, you just need to finish this. and then work on this book assignment on 743. I will tape that day as well so that it's online, okay? Anybody have a question about what's going on? Tomorrow's the quiz. Wednesday is this